So welcome to my mathematics videos as we continue with sequences and series. But this time we are focusing on geometric progression, commonly known as GPs. And in the ECZ examination, you are going to find geometric progression specifically in paper 2. So what are some few concepts that you need to remember? Well, imagine that you have got a sequence, a pattern that you have there's a sequence in a number. For example, you have got the first term, term 2, and term 3, and you are told that this is a geometric progression. You need to remember that for a geometric progression, we are going to be talking about the common ratio. So in this case, for you to get what we call as being the common ratio R, you simply need to divide two consecutive terms. For example, T1 divided by T2. This is also going to be the same when you take T3 divided by T2. So the two consecutive terms, when I mean consecutive terms, I mean terms that are following each other. So you cannot take this divided by that. That would be wrong. So you only take two terms that are following each other. And of course, the value that you get between dividing this one and that one should always be the same. That is what you need to remember. And that concept later on is going to be used. Now, in a geometric progression, if you know the first term and you want to know the second term, so what we do, for example, if I know my T1 and I want to know the next term, so for you to get term 2 there, you just need to multiply the common ratio that you get by the first term. And again, for me to get the next term that follows there, again, you keep on multiplying by the common ratio. So that is how you can get, terms in a geometric progression. As long as you know the first term and the common ratio, you can know the term in any position. Now, another concept that I want you to pick up is that the formula, so the formula that we use, so the formula, for the nth, term, the nth term in a GP, a geometric progression, is simply given by Tn is equal to the first term multiplied by the common ratio, then raised to n minus 1. Remember, the r is raised to n minus 1. So this is a formula that we are going to be using if we want to find the formula for the nth term. So that is what you need to remember there. Other concept that we are going to talk about that I want to bring to your attention is that you also need to know they are going to tell you to find, the sum of, n terms. So they can also tell you to find the sum of n terms. So what do you need to do when you are told to find the sum of n terms? Well, it is not complicated as you may think. So there are two things that I want you to always be remembering when you're finding in a geometric progression. If you want to find the sum, there are two formulas that we can apply. Sn is equal to the first term, then 1 minus r raised to the power n divided by 1 minus r. But when do we use this one? We apply it when our common ratio is less than 1. As long as our common ratio is less than 1, you can use this formula to find the sum of n terms that you have. Another one that you need to remember is that Sn, this formula can also be written as a r raised to the power n minus 1 divided by r minus 1. You can notice if I start r minus 1, it is also r minus 1, but this one is r raised to the power n. So when do you apply this one? We apply this one when our common ratio is greater than 1. So when our common ratio is greater than 1, then we are going to be applying, this formula here. So that is what we are going to do, right? Again, the last thing that they are going to be asking you is to find sum to infinity. So if they tell you to find sum to infinity, we use that symbol. That's the symbol for infinity. Yeah, when our n is going to infinity, that is what we mean in our situation. So when our value of n is going to infinity, so we can apply the formula, the sum to infinity is equal to the first term over 1 minus the common ratio. But when do you apply this one? We can simply say when, we can say that a -1 should be less than r and r should be less than 1. In simple terms, you can apply, the sum to infinity when the modulus of the common ratio is less than 1. That is what we mean. So basically, you need to remember all these formulas that we have talked about here. So the formula for the nth term, when you're finding the sum, there are two formulas. Remember, depending on the value of your common ratio that you get, and also what we are calling as being the sum to infinity. That is what we mean. Now let me show you a pattern in what we are calling as being a geometric progression. Imagine that you have the sequence. Let's say that you have the sequence 2, 4, 8, 16, 32, and so on and so forth. You notice something there. They can tell you to find the common ratio. So how do I get the common ratio? Remember, this is my first term that I have in the sequence there. But this is my first term, this is my second term, my third term, and so on and so forth. So when you get 4 divided by 2, what will that give you? To give you 2. It should be the same even if you were to get 8 divided by 4, it will still give you a 2. Now imagine that you knew that your common ratio is a 2 and you knew the first term. In this case, our first term is a 2. We can get to know the next term. We just say 2 multiplied by the common ratio, which will give us so multiply by the common ratio, which will give me a 4. Again, 4 multiplied by the common ratio, that's what we mean, it will give us 8. Again, 4 times 2, which is the common ratio, 16. 16 times 2 give you 32. So you can have, a lot of terms. So that is what we mean there. So you shouldn't actually be struggling with that. Well, let's look at some other quick examples and see how you can find the common ratio. For example, I can tell you to say state the common ratio over, maybe let's say A, you have a sequence 12, -4, 1, 1 over 3. Then maybe B, you have 1 over 2, 1 over 3, and 2 over 9. Maybe you also have a sequence, let's say, 10, 2 over 3, 16, and 24. Usually people, when they are getting the common ratio, they easily give up because maybe they are able to see fractions. No, you shouldn't give up. It is actually simple. So let's try to see if we are able to get our common ratio. All right, remember, to get the common ratio R, you divide the term by the preceding one. That is what we mean. So in this case, for my first one, the common ratio there, it is going to be -4 divided by 12. Of course, -4 divided by 12. If you want, you can write, remember, this can also be written as -4 divided by 12. Yeah, 4 there is simply 1. 4 into 12 is a 3. So your common ratio there is -1 over 3. That's what you need to remember. B, you have that one again. How do you get the common ratio? So it's the, we divide a term by the preceding one. So you get this one, you divide by the preceding one. So it's like 1 over 3 divided by 1 over 2. But remember, this again can be written as 1 over 3 divided by 1 over 2. So what is 1 over 3? Remember, when you change your multiplication, your division sign to multiplication sign, this number, to your right, we exchange. The 2 goes up, the 1 comes at the bottom. So it is going to be 2 over 1. So 1 times 2 is a 2, and 3 times 1 will give you 3. So the common ratio is simply 2 over 3. So that is what we mean. So there's nothing complicated. You just need to practice. All right. Let's look at, C there. It says they have given you, so to find the common ratio, you get your 16 divided by 10, 2 over 3. But of course, you can change that one to you can change it to an improper fraction by simply saying 3 times 10, that is 30 plus 2, that is 32. So it is like 16 over 32 over 3. But remember, this can be written as 16 divided by 32 over 3 for simplicity's sake. When we change to multiplication sign, that number 16 can be written over 1. When we change to multiplication sign, this goes there and this comes there. So it will be 3 over 32. So what will that give you? Remember, 16 there, 1, 16 there, goes there 2 times. 1 times 3 is a 3, and 1 times 2 is simply a 2. Of course, you can leave it as a fraction, 3 over 2. So that is what we mean when you are finding the common ratio. So it's not something complicated. What is important is for you to practice. Okay, let's do a typical question and try to apply the concept that I've given you so far in our discussion. So let's try to use that one. For example, let's call it as being example number 2. Consider the geometric, let's say consider the terms in a geometric progression. So they give you 128, 64, 32, and so on and so forth. Then the question says that, find A, the 12th, term, then B, we can say the formula. So we can say the formula for the nth term. So that is what we mean. So how can you go about this one? Well, it's very simple. You don't even need to worry. So remember, in your paper 2, like I said, you'll always be having geometric progressions. Just stay tuned and pay attention and see how you can go about that. So since the question, they have given you that, what do you need to know? So they have given you the sequence 128, 64, and also 32. That's what they have given you. What is the term? The first term in the sequence. So the first term, remember, the first term is given by A, which is 128. Then we need to know the common ratio. What is the common ratio that we have? You get your 64, you divide by the preceding term, which is 128. Of course, when you say 64 there is 164 there, and that will give you a 2. So our common ratio is a half there. So that is what you need to remember. So now, since they are saying the 12th term, meaning that when n is equal to 12, so you apply the formula for the nth term, Tn is equal to the first term times the common ratio, but raised to n minus 1. All right. So it will be T, the 12th term for T12 is equal to, what is the first term there? It is simply 128. Of course, multiply by the common ratio, which is, let me just say, multiply by 1 over 2, but this raised to, what is my n? It is 12 minus 1. So T12 will be equal to 128 multiplied by 1 over 2 raised to the power 11. So you can use your calculator and actually work out that what is 1 over 2 raised to the power 11. But of course, according to, you can also apply the laws of indices. It is possible that you can actually apply the laws of indices. For example, if I look at this one, but of course I don't want to confuse you, that 128 can be written as 2 to the power 7. And remember, we did say if you have a number a over b raised to the power n, that means a to the power n and b to the power n. So it's the same way there. If you actually look at it, it's like me saying 1 to the power 11 over 2 to the power 11. But of course, 1 to the power 11 will still give you 1 over, then that is 2 to the power 11. This can be over 1, so that will be this times that will give me 2 raised to the power 7 over 2 to the power 11 there. You can apply the laws of indices there. So you can apply the laws of indices when you're dividing. What do you do to the power? You subtract. So it's like 7 minus 11. And if you look at 7 minus 11, that will give you a negative 4. But this can also be changed to that negative 1 as a reciprocal. So it will be 1 over 2 raised to the power 4. So what is 1 over 2 raised to the power 4? It will give us 1 over 16. So that is the value we are getting. But I know, of course, you think that is complicated, but if you know the laws of indices, you can easily apply that. But let me show you the easiest way. Since in paper 2 they require you to use a calculator, you can just say, what is 1 over 2? So you can put that one in your calculator, 1 over 2, close bracket, then you simply raise it to the power 11. So what is that giving me? It is simply giving me 1 over 2048. So that's what it's giving me. So this multiplied by 128, it is going to give me a 1 over 16. So that is the term in the 12th position. So the 12th term is simply going to be 1 over 16. So please pay attention even as much as you multiply that. Right, let's look at the B part. The B part there says the formula for the nth term. Remember what we said when the question says the formula for the nth term, it simply means you do not know what your n is. It can be at any position. But your first term, yes, you know it's 128. Your common ratio there, we know it is 1 over 2. So to find the formula for the nth term, what we do is that we replace on the first term and the common ratio, but we don't replace on n. And when you reduce it to its simplest form, that is what we call the formula for the nth term. So that is going to be Tn is equal to the first term is 128 multiplied by the common ratio is 1 over 2 raised to the power n minus 1. Like I said, you can apply the laws of indices. When I look at that one, according to the laws of indices, remember I said if you have a over b raised to the power n, that is the same as a raised to the power n over b raised to the power n. So this is the same 1 over 2 raised to n minus 1. I can also write it as 1 n minus 1 over 2 n minus 1. So that's the way I can actually write that one. But remember, 1 raised to that will still just give you 1 over 2 n minus 1. So that's the idea that we are going to have. So this is going to give us a Tn is equal to, remember, in terms of 2, if you are not so sure, you can get your 128 and start dividing to 2 there. It is going to give me 64. 2 there will give me 32. 2 there will give me 16. 2 there, it will be 8. 2 there, it is going to give me 4. 2 there, it is going to give me 2. 2 there, 1. So how many 2s have gone into 28? 1, 2, 4, 5, 6, 7. So meaning that your 28 can actually be written as 2 raised to the power 7 multiply. Remember this, I can substitute it with that. It will be 1 over 2 n minus 1. I just want to reduce this term. So this times that, it's over 1. This times that will give you 2 raised to the power 7 over 2 n minus 1. According to the laws of indices, when you are dividing with the same bases, what do you do to the powers? You subtract. So it will be 7 minus n minus 1. So what will this give me? Remember, if you look at it typically, you are going to find 2 negative times that, so it will be negative. When negative times negative will be positive, like terms on one side. So when you add 7 plus 1, so that will be 2 raised to the power 8 minus n. So that is going to be 8 minus n. So remember, you need to go back to your laws of indices. I know it appears to be complicated, but just go through the laws of indices. Well, thank you so much. Watch out for some more practice, questions as we look at how to find, the sum and other things. All right.